Okay, so this video is for Mrs. Vaughn's Algebra 2 class. This is the review or the finish of the review for sections 1.2 and 1.3. I did a dumb and left my pins at home, so I'm going to try to do this with my finger, which should end up being interesting, but we'll try. All right, so it's going to be a little bit backwards for the students that were in class today. I'm going to go and finish 7 and 8. See, it's going to just do this the whole time. We'll see if I'll be able to move my page at all. So yeah, we'll do 7 and 8, and then once that's done, I'll let you guys know. I'm gonna go back and start back at the beginning for any students that were absent today on Thursday, September 1st. So anyway, so that's what we'll do. Okay, so let's go ahead and get started. So seriously, this is gonna drive me insane. No, erase it. Please, please, erase. Oh man. There we go. Okay. Okay, for 7, we have negative, let's see, negative 3ab squared. So there's no negative exponents, which means that's going to stay in the numerator. And but we have a plus 2b negative 3. So we know that a 2b with a negative exponent is equal to 1 over 2b cubed. So we're going to stick that in the denominator when we simplify it. So just so I can have room, because otherwise it's going to be a mess. Let me zoom in, see if this will work. Okay, so when you simplify that to get rid of, and also that b to the power of 0, this guy right here, that's going to end up being 1. Seriously? It's going to end up being a 1. So we can just eliminate that as well, because anything times 1 is itself. So let's go ahead and simplify this. So we end up with negative 3ab squared divided by 4ab squared minus 5a squared. That b is kind of nothing, plus 2b cubed. Let's see here. Negative 3ab squared. So we do have a like term here. We have that ab squared. So we should be able to eliminate that. Let me just check myself for a second. Okay. Okay, so remember when you are adding and subtracting terms, they have to be like terms in order for you to combine them. However, in this case, excuse me, the AB is going to be, these are like terms. Let's see, just get a different color. This one right here and this one right here. So we can combine those. Let's see if I can get rid of that. Yep. All right. And actually eliminate that. Yes. Okay. So those will actually cancel each other out, and we'll end up with negative 3. And you can keep that in the numerator if you want, but just remember, if the numerator is negative, you can just throw the negative in front of the whole fraction. Over 4 minus 5a squared plus 2b cubed. So select, if we put those in order based on our exponents, the one with the highest exponents goes first, then this is negative 3 over 2b cubed minus 5a squared plus 4. And that's our answer. And so that one's pretty simple. As long as you are good with the concept, oh, that's awful, that a negative exponent means it's a reciprocal of what you're looking at. So instead of being 2b to the third, 2b cubed, it's actually 1 over 2b cubed. Then you move it to the denominator, as well as eliminating that b to the power of 0, because a 0 exponent is just the number 1. So we can eliminate that as well. So those were the main, oh, for crying out loud, the main points of this problem here is the negative exponents, as well as the 0. Okay. All right, moving on. Last one. I know this one looks like a doozy. It's really, really not that bad. But the problem of this one is combining like terms. So we already did this. For those of you in class, we've already had some experience with this, so you should be good. But the nice thing about this is because you have a plus sign between these two parentheses, the parentheses are actually unnecessary. They're sort of a just an unnecessary distraction, because you're not having to distribute a -1, which a subtraction would give you, into that second trinomial, the 2xy to the power 4 minus 3x cubed y squared, etc. Okay, so you can just kind of ignore those, eliminate those if you want to rewrite it without them. But the point here is to find your like terms. So we have 2x cubed y squared, and over here we have a -5x cubed y squared. Remember, always include the operator with the term that follows it, because you're going to be combining those. So you need to make sure you know this is 2 minus 5. So you're going to end up with a -3. Okay, and the next one, x squared y to the third. We do have one of those, right? This -5x squared y cubed, and -3x squared y cubed. And then our last one, oh no, I'll just use a pink, I guess. 4 is this xy to the fourth and xy to the fourth. Yep, so these guys go together as well. Oh my goodness. Don't come at me for overlapping my different highlighters. All right, so we're going to combine these two, and then these two. And once we're done, we're not going to be able to do anything else because they're unlike terms separated by addition or subtraction. So we can't combine them anymore. So that's pretty much it. So 2x cubed y squared. So you can do this a couple of different ways. You can put them in order, which I feel like is helpful. So 2x cubed y squared minus 5x cubed y squared. So you can use the distributive property I guess it's sort of distributive property in reverse here. You can actually extract the 2 minus 5 from the variables x and y, and you end up with x cubed y squared times 2 minus 5, which I know is kind of a weird order, but we'll fix that, equals, then you see you've got 2 minus 5, so it's -3x cubed y squared. If you don't need to do the distributive property, just kind of treat them like two numbers that you can just combine, then just, you're doing 2x cubed y squared minus 5x cubed y squared. You get it up, same answer either way. I'm going to probably run out of room doing it this way. Let's see. Okay, so either way, so this is our first simplified term. All right, the next is the -5x squared y cubed minus 3x squared y cubed. And these are like terms. We have -5 minus 3. So that's like a -5 plus a -3, x squared y cubed. And so that gives us -8 x squared y cubed. Excuse me. All right, last, so that's our second simplified term. And then the last one is the pink one. All right, so this one is 4xy to the power 4 plus 2xy to the power 4. And again, we're combining the 4 and the 2. So 4 plus 2 is 6. So 6x y to the power 4. So I think I've used up, well, I got a little room over here. So now you just combine them. Order, I don't suppose would really matter. Just for simplicity's sake, I'm going to put the 6xy to the fourth since that's the only positive sign term we have here. And I hate starting them with a negative number. So your final answer is 6xy to the fourth minus 3x cubed y squared minus 8x squared y cubed. And I'm so sorry that's so messy. That's the best I can do with my fat fingers. All right, and that's our answer. That's as simplified as this problem's ever going to get. And that's it. So for anybody who was in class today, that should cover the rest of the review guide. Excuse me. So I'm going to go on back to the beginning for anybody that wasn't here. Hopefully I will see y'all tomorrow. Okay. So for number 1, in this case, so for 1, 2, and I think 3 as well. Yeah, for 1, 2, and 3, the first 3 problems, they've given us a value for x and y. So what we're really learning here is how to plug those in correctly, the values for the variables, and then solve for an actual number, an actual solution to this algebraic expression. So make this bigger. I really hope. Yeah, okay. I don't know why. I'm always terrified that I've gone for like 15 minutes and haven't recorded myself. All right, so now that let's see here. Yeah, I'll just get my values in front of me. All right, so the biggest thing to remember is when you are plugging in a value for a variable, especially when you have an exponent, you need to make sure that the value is in parentheses, particularly if it's negative, because obviously a negative number to a positive exponent is going to give you a positive answer, right? -3 times -3 is a positive 9. So use parentheses if you need to, so you don't accidentally get your signs mixed up. All right, so this one is 2 times x to the third, and x is 2. So plug in the value of 2 there, plus the y is a -3 to the power 3. Now that's an odd exponent, so you know your answer is going to be negative, or your simplification for that exponent is going to be negative because it's odd, but we'll get to that in a minute. So this is 2 to the third is 8, and 8 times 2 is 16. Plus 5 over 3 times 3 times 3 is 27, and it's an odd number, so it's going to be negative 27 over 5. So fun time. Now we've got to combine a whole number with a, excuse me, with a fraction. So in order to convert this, we've got to multiply that 16 times 5 over 5. And that's going to give us, I think it's 80. Yeah, 80 over 5. And adding a negative number is just the definition. Yeah, adding a negative number is the definition of subtraction, pretty much. So this can just become, because the 80 is our larger number, we don't really have to worry about like or unlike signs. We can just do regular old subtraction. And you end up with 80 minus 27 over 5. I'm going to bring that down so that I don't butt up into my number 2. So 80 minus 27 is 53 over 5. And you can go and you can leave it that way, perfectly fine. Or you can turn it into a mixed number, which is 5 goes into 53 10 times with 3 left over, 3 over 5. So either one of those is an acceptable answer. Okay, moving on to number 2. All right, so we had a conversation about this. You could either simplify this by going ahead and distributing that square into the x and the y. So you get x squared plus y squared minus x squared plus y squared. But in this case, it would be very important to go ahead and solve them, or go ahead and plug in the values and solve inside the parentheses first. So we're going to do, oops, wrong button. All right, so x is 2. So this is 2 plus -3 squared minus 2 squared. It's positive, so I'm not worrying about the parentheses. However, the y is negative. So this is -3 squared. All right. So the reason it's important to plug in your values first is if you didn't, I'm pretty sure you would accidentally end up with an answer of 0, which this is not, because you'd end up with x squared minus x squared and y squared minus y squared, which will give you 0. But that's actually not the case. So we want to put in the values first and then simplify. So this is 2 squared, which is 4 plus, no, sorry. Here I go again. Yeah. See if I can do this. Okay. All right, 2 plus a -3, sorry, is actually -1. You do it either way, but whatever. Okay. That gives us -1 squared minus, this one is 2 squared, which is 4, plus -3 times -3, which is actually a +9. And then -1 squared just gives us a +1, minus 4 plus 9, which is 13. And we have unlike signs here. So this is actually 1 plus a -13. That shows you have unlike signs. So you take the negative to your answer bar because that's the larger absolute value. And then 13 minus 1 is 12. So your answer here is -12. Okay. Moving on to number 3. Number 3 looks intimidating. It's really not. What we ended up doing in class was I actually used the properties of exponents to simplify my division before I actually plugged in the values of x and y so that I wasn't running into the error, the potential for careless errors when raising these numbers to these higher exponents of 4 and 6. So we can't really do anything with the variables that are separated by plus and minus, but we can do this. So if you remember from section 1.2, your quotient property of exponents tells you that any dividend, which in this case is x to the 4th, divided by the divisor means that you subtract your exponents. So this is 4 minus, so this is x to the power of 4 minus 6, which is x to the power of -2, which I know is not nice because that gives us a fraction. That's okay. So that means that this is actually going to be 1 over x squared. That's this guy. The other one is y to the power of 6 divided by y to the power of 4. So that's 6 minus 4. And so that gives us y squared over on the far right. So when we plug those values in, we end up with, erase that. Okay. We end up with x cubed plus our 1 over x squared minus y squared. Now it's much simpler, smaller exponents. So we can go ahead and plug in our values for x and y. So x is 2, so this is 2 cubed, plus 1 over 2 squared, minus -3 squared. So remember, with that being a negative, keep it in parentheses so you don't get, you don't mess up your actual signs when you complete your exponents. So order of operation tells us to go ahead and solve our exponents. So 2 to the 3rd is 8. This is 1 over 4. And this is minus -3 times -3 is 9. So in this case, and what we did in class, was we took our whole numbers and went ahead and reduced those. So 8 minus, I don't even know what color I was, blue. 8 minus 9 is -1 plus 1/4. So in this case, you might be able to see, because these are pretty small, you can see that your answer is going to be negative, and 1 minus 1/4 leaves us with 3/4. So your answer is going to be -3 to the -3/4. But if you need to see the math, just follow along here. So if we're doing the math, then we have -1, which I'm going to turn into -4/4, same thing as 1, plus 1/4. And you can see that we have unlike signs, and our larger numerator is the 4, so our answer is going to be negative. And so it's just 4 minus 1, which is 3, and you have -3/4. Okay. Let's move on. So for the rest of these, we're simplifying. For number 4, it's all numbers, no variables. So we actually are using order of operation and our understanding of adding, subtracting, as well as multiplying and dividing by negative numbers. Excuse me. And then once we get to number 5 and number 6, we're using the distributive property as well as our properties of exponents to simplify. But we're going to end up with a algebraic expression instead of just a single integer as our answer. Okay, so for number 4, first we want to look at our grouping symbols. So at this point, I kind of want you to think of PEMDAS as GEMDAS, right? It's not parentheses all the time. It's also other grouping symbols, one of which, a very important one, is your absolute value. So first, I'm going to simplify my numerator, then I'm going to simplify my denominator, then we're going to put them back together to solve. All right, so for the numerator, we have -2. I'm going to kind of leave that alone for a second. Well, no, better just put it all together. -2 minus 10, but let's go ahead and simplify inside these parentheses. So in this case, this -2 is not in its own separate parentheses, separated from the exponent. So this is actually negative, or a subtraction of 2 squared. So this one actually is going to be -4, right? Because that negative sign is not inside parentheses. So it's not -2 times -2, it's just -2 times 2 plus 3. All right, so that simplified that. So again, let's solve inside those parentheses. We have -2 minus 10, -4 plus 3 is -1. Excuse me. All right, so let's go and do our multiplication, which is this 10 times -1. So this is -2 minus 10 times -1 is -10. And that's just -2. Oh, did I really just do that? Let's see here. It's -2 plus 10, which is 8. All right, so there's our numerator. All right, 2 is our denominator, negative absolute value of 4 minus 6. So all you need to remember is that everything inside of an absolute value is going to come out positive. So if you have a negative in front of an absolute value, your answer is always going to be negative. So I'm just going to leave that there. Solve inside my absolute value. 4 minus 6 is a -2, but we know that the absolute value of any number is positive. So my answer here is -2. That's my denominator. So then when we go ahead and solve it, part 3, we put the 8 in our numerator, we put the -2 in our denominator, and we know that if we're multiplying or dividing and there is an odd number of negative signs, our answer is always going to be negative. So 2 goes into 8 4 times. So our answer, -4. Okay, good. Okay. Moving on. I know these look intimidating, but once you understand the process, they're really not that hard. This is where we use our distributive property very, very carefully, because we don't have values for x here. We have no idea what that number is. So we cannot combine any terms that are separated by a plus by addition or subtraction unless they are identical, same variable with the same exponent. So we've got to distribute. So all we're going to do is we're going to distribute this guy into here, and we're going to distribute this negative, just keep the negative, into this entire thing. Okay, so when we do that, we end up with 2x cubed. So again, this is 2x cubed times x squared. So if you use the product property of exponents, then this is 2x cubed 3 plus 2 plus 2 times 3 is 6, and x cubed 3 plus the understood exponent of a variable with no exponent is 1, not 0, 1. So you must add a 1 because we just went from having 3 x's being multiplied to 4. All right, and so then that simplifies down to 2x to the 5th plus 6x to the 4th. Excuse me. All right, then we combine the negative 5x to the power 4 with the x, negative 8, and x to the power of negative 1. All right, so this is negative 5x to the power of 4 plus 1, because remember that's an understood exponent of 1, minus negative 5 times negative 8 is positive 40. That's why we take our sign. And then the exponent doesn't change, x to the 4th, plus this, no, let me just go ahead. Dadgummit, why does it keep doing that to me? Erase, erase. Please erase. Thank you. Nope. Draw. Okay. Yeah, this is negative, right? Negative 5 times understood coefficient of 1 is still negative 5. So negative 5x 4 plus negative 1. Still adding our exponents. That's all we're doing. So when we simplify that, we end up with negative 5x to the power of 5 plus 40x to the power of 4 minus 5x4 plus negative 1 is x to the power of 3. So we just go ahead and combine all of those. Let's see. I'll just rewrite it. No big deal. All right. Actually, we've got it all right here. We can do it here. These are all like one expression. So let's go ahead and highlight our like terms, if you don't mind. We have 2x to the 5th, and we also have negative 5x to the 5th. And then we have we do have an x to the 4th. X to the 4th, sorry, 6x to the power of 4. Okay. And 40x to the power of 4. And then that 5x cubed, there's no like term to combine it with. So we're just going to tack that onto the end. So 2x to the 5th minus 5x to the 5th is negative 3x to the power of 5. 6x to the power of 4 plus 40x to the power of 4 is 46x to the power of 4. And then we're going to add on that negative 5x cubed. And that is as simplified as we can get it because there are no more like terms that we can combine. All right, one more and then you're done. All right, this guy, this guy had everybody stressed, but there were some light bulbs, so there's hope yet. Okay, first off, this guy right here, anything to the power of 0 is what? 1. 1. And what's anything times or divided by 1? Itself. So you can just completely eliminate that from the problem because it's just a 1. Just ignore it. Okay, now we have 2 negative exponents. So remember that a negative exponent, you can just think of it in terms of a negative exponent is equal to the reciprocal or its reciprocal with a positive exponent. So let me show you what I'm talking about. B c squared to the power of negative 1 is equal to 1 over b c squared. We don't need that 1 anymore because the 1 is understood. Anything to the power of 1 is just itself. And then the a squared b cubed to the power of negative 2 is just 1 over a squared, I need parentheses, b cubed. Now you do have to keep that power of 2. So we're going to do our product property to simplify that that a little bit more, but that's it. So let's go ahead and do that. That is 1 over a 2 times 2, that's a to the 4th. So remember, when you have an exponent raised to an exponent, you multiply them instead of add them. And then this is b to the 6th. So 1 over a to the 4th, b to the 6th. So, but these two, you don't forget, they're separated by a fraction bar. So this is a fraction, 1 over bc squared, divided by the fraction 1 over a to the power 4, b to the power 6. So write it as a division problem, if that helps you, because that's what I know we all learned in grade school with our arithmetic. So if we rewrite that, instead of using a fraction bar, you can say 1bc squared divided by 1 over a to the power 4, b to the power of 6. So what do we do when we divide fractions? We switch our division to multiplication, and we multiply times the reciprocal, which means, oh, let me give myself more room. Hold on. Okay. So change that to multiplication, and this stays 1bc squared times a to the power 4, b to the power of 6 over 1. Excuse me. So also when you do this, when you're multiplying fractions, you know that you can reduce or cancel between the numerator and the denominator. So you have 1b in the denominator of the first fraction, and then you have b to the power 6 in the second one. So you can, that's pretty much the b to the 6 minus 1. So it cancels this guy out, and this becomes, oh, that's so messy. It's driving me crazy. That becomes a 6 minus 1. So simplify again. This equals a to the power of 4, b to the power of 6 minus 1, which is 5, over c squared. And that is your final answer. Also, and this is again, this is something I said in class, so maybe this helps you. But if you see a negative exponent, especially when you've got a fraction bar like this, that means just take the denominator with the negative exponent and put that whole term in the numerator, and take the term in the numerator and put it in the denominator. And when you see that we end up with this guy right here, before I started crossing things out, but you can see if you flipped them, it gave you a to the power 4, b to the power 6 in the numerator, and bc squared in the denominator. And then we just reduced it. Either way, you can work through the math if you want to use the steps and not second guess yourself, or if you just understand that if you see a negative exponent, you can just put it in the, like if you see it in the denominator, put it in the numerator. If you see it in the numerator, put it in the denominator. And then the exponent becomes positive instead of negative. I'm sorry, I hope I haven't made it more confusing, but that's just another way to look at it. And that's pretty much it. If you can get through these and kind of understand what's going on, you should be in good shape for the quiz. This covers everything that we have. The only other thing is, hopefully you were here for the worksheet with the, okay, so at the beginning of section 1.2, there's a box with all of the exponential properties in it. So it's got the product property, the quotient property, the power property, and it gives you an example of negative exponents and an example of the zero exponent. So that is the only other thing I would make sure that you have in your notes or available or filled out for the quiz that we have tomorrow. All right, that's pretty much it. So sorry for being so extra tonight, but hopefully this helps, and I will see you guys later. Thank you.